employees. Great. Got it. Advocates work with unhoused individuals or disabled individuals to take them through the process, which can, have multiple court hearings, submissions, rejections, appeals. It's quite a complex process, but the outcome hopefully is that person gets into stable housing, or at least stable income to help them, get above where they are at the moment. So we have a case management tool that the advocates use to help manage those processes. So that's used by local governments like counties and by non-government organisations. So we're in the process of relaunching that software. We wrote it about 3 years ago for the city of San Francisco. And there's been an opportunity now for that to be adopted statewide in California. So we're currently going through the process of uplifting some 3-year-old software to make it, multi-tenanted for multiple clients, and hopefully get that into people's hands shortly. So we're based here in Cape Coral. Other founders are over in Oakland. We've got people working remotely in Florida, people working remotely in Oregon. So we're a fully remote company, hopefully growing later this year. So tonight's talk is about infrastructure as code, how we are using that at Ascent Populi. This is the culmination of a work practice I've kind of been working on for the last 4 or 5 years with different companies and different technologies, but pretty happy with the way it works. If you haven't used infrastructure as code in your current organization, this is really how we do things in the future. It's just, I don't even deploy test code or test cases without going through a like Terraform to deploy that and manage it. Like I don't use the AWS console for anything now except for checking logs. Like we don't do any deployment of resources or assets through there at all once we get our initial environment set up. There's 2 aspects to IAC, the orchestration, which is provisioning the infrastructure in the first instance and configuring it, and then you've got the management of it on an ongoing basis. So changing resources, deploying code artifacts into production. There's things you do after you stand up the infrastructure in the first instance. So the big thing about what we're doing here is that all of your configuration is scripted. You're not manually configuring variables or settings or calls or memory anywhere. You're creating code for that using repositories to maintain that code as if it was software code, and using a platform to deploy those changes into an infrastructure environment. So HashiCorp Terraform is the product I use. It's akin to AWS's cloud formation, but it's multi-cloud. It can cover this probably 1,000 different infrastructure platforms and software as a service providers available for it that you can interact with. It's really quite pervasive. You define resources, like for example, an EC2 server. You define it as a resource using some scripted code, and you execute that code against the host, like AWS, for example, and it will take your configuration and it will deploy that instance based on what we've configured in the code. You can make changes to it. You can check it into GitHub. There's deployment workflows that you can go through. You can lock out your developers so that you don't have ghost infrastructure. No one can start a mining instance somewhere that you don't know about in another region somewhere, because you can lock your accounts down. So everything has to go through this process to be deployed and managed. There's 2 ways you can interact with Terraform. You have command line interface for doing it locally, or you can use the Terraform cloud platform, which is what we've migrated to, which is a hosted solution, but also allows you to do nice things like have teams, different levels of permissions, etc. So what we're doing tonight is, first half is like presentation. The second half, I've got a demonstration where we're going to go through and show how we use scripts to create workspaces, how we use the scripts to pull resource configurations from a repository, and we'll actually run one of those and deploy new infrastructure live. Hope it works. So what makes Terraform tick with all these different cloud providers is something called a provider resource. The provider basically is the bridge between Terraform and the infrastructure API of AWS or Azure or somebody like that. So if you're interacting with AWS and with MongoDB, I use those two providers, and those providers interpret the configuration that's been built for each of the resources you want to deploy on those different destinations, and they interact with the API of that service provider. Like, for example, with MongoDB, for example, to create the resource I want in the Mongo environment. With multiple providers, you can manage resources across multiple clouds. So the example we're looking at tonight is deploying a backend for a web-based application. So we're deploying Graphql, deploying Lambda resources for that Graphql, and also deploying credentials on a MongoDB cluster that those Lambda resources can access and use to interact with the data. So we run one workspace and we deploy an entire backend and on both AWS and on MongoDB's cloud service. We are dealing with APIs. You are dealing with sensitive things like access keys, for example. Talk tonight a little bit about how you keep those things out of GitHub. Most employers these days, if you're asked to submit a Git link for, show some of the work that you've done, they're going to crawl those and look for things like connection keys and access keys and things like that to make sure that you're not the sort of person that checks keys into repositories. One of the things to be aware of. So here's an example of what a provider looks like in terms of the configuration. This is, the top one is what a local provider might look like, and the bottom one is what it might look like if you're using environment variables to be safe. So when Terraform first came out, you put your access key, you put your secret key in, people check these things into GitHub. You'd have to be quite explicit about the credentials you're providing. Now we use environment variables. It's quite secure, and you don't have to worry about checking your configuration into a repository and checking in your keys with it. So this bottom provider here, you can see here, it's a provider for AWS. We pass on the Graphql, which is the ARN of a role, like an IAM role in AWS to adopt, and Terraform will use that role to interact with AWS to do all the provisioning of resources and changes that it needs. And we'll look at some this once we get to a demonstration. When we look at resource configurations, there's the ability to put these into modules, so you can make reusable patterns. For example, my virtual private cloud or VPC configuration, I use that across multiple projects. So I can define that once, check that in, and I can reuse that across different projects as I need to. You can have variables that you pass into these configurations. For example, if you have another VPC that you need to get the ID of and pass in, or it might be like how many seconds a resource runs for before it times out. You can pass those in as variables. And you can also pass outputs from the creation process. So if you create a VPC, for example, you can pass out the ID of the security groups that you've created in there that other resources might want to use downstream. So it allows you to do modularization of your infrastructure configuration, and that basically results in, you might have multiple GitHub repositories that manage all of your infrastructure. You can do it as a mono repository if you want, and just have particular branches under your repo that relate to specific workspaces that you want to use. And a lot of this will make much more sense once we get to the demonstration and start looking at it. But hopefully when you start to see some of this stuff, some of the things I said now might ring a bell and make sense. So here's an example of what I was just mentioning there. We have a variable, which is the ID of a virtual private cloud on Amazon. We have a resource definition over here on the left-hand side, which is for defining a new security group for outbound traffic. This might be for a web app or a EC2 instance, for example, if it's got a web server running on it. So we pass in the ID of the virtual private cloud that this security group is to be created within. And you'll see there, top 3 feet down from the top, the VPC ID is the variable. One of the outputs though, because we need to use this security group in other workspaces, is the ID of the security group. So when we create this in Terraform, we have the ID available of it to other systems. So when I deploy Lambda functions, for example, if they need outbound traffic, they might be associated with this security group, and it's all parameterized between it. You don't have to copy stuff from the console, put it into configurations, things like that. It all passes through outputs from one, becomes the input to another. Just behind the scenes, the way Terraform manages the infrastructure is by maintaining a state of what it expects to be running on the particular cloud. So it uses JSON to maintain a state of what it expects to be deployed. And when you run a workspace again, it looks for changes between what it's expecting to exist and what it's planning, but looking at the current configuration. And you can run the state locally on your machine, like you might be a single developer just doing something from your own machine. You can have state running locally. You can have your state in a remote S3 bucket, so it can be shared amongst multiple developers, or you can use Terraform Cloud to maintain that state, which is generally the way most people do it. And not that you ever need to look at the state, but that's the state for that particular security group that we would have created before. I never look at this stuff in practice, but it's an example of how the resource that's being created exists here in a state document. We can see the description as blank, for example. So if I change my configuration and added a description or a tag to my security group, and I run it again through Terraform, Terraform's going to look at what the resource code says versus what the state says. It's like, oh, there's a description before, the description was blank. I have to make this change, and it's going to plan that change, and it'll use the AWS API to go ahead and make the changes to that security group. But in practice, you never look at this stuff. As I touched on a moment ago, there's 3 ways of using Terraform: local with a local state, local with remote state, or using the Terraform cloud. I actually do use local with a local state as part of my CI/CD, because I use that for promoting code artifacts that I compile on my machine into a destination bucket for deployment, and then later Terraform Cloud picks those resources up from that bucket and puts them into an execution bin somewhere. So the demonstration we're looking at, we'll be doing both local state and a Terraform Cloud. I've mentioned Workspaces a few times already. Getting to showing a workspace will make this make a lot more sense, I guess. But really what you do is you break your infrastructure down into multiple workspaces. All of your networking, for example, things that stay relatively static. If you have database clusters, for example, you might put those into their own workspaces. If you have user stores, they go into their own workspaces. But then you might do projects. So for example, a web application, you might have a React web app that's got a GraphQL backend. I like to put the front end resources into their own workspace, or the back end server resources into their own workspace. And they'll do things like they'll use the network resources created in another workspace, using that output and variable model to exchange information. The nice thing that you'll see when we get to a demo is the abstraction of infrastructure. I don't need to know the IDs of security groups or the VPCs, or if I set the region at the very beginning, all this stuff just talks to each other, and it's all in variables. It just makes things so much more simple than if you've ever sat down and tried to configure a VPC, configure a security group, configure outbound rules, all this sort of stuff. Once you've scripted it once, it's just reusable across multiple projects. So this is what Workspaces might look like in Terraform Cloud, for example. This is just part of the UI. We'll get to the demonstration and show ones I'm actually using at the moment. But like you can see here, I've broken down Workspaces into VPC, or the networking. I've got my user stores, one location, data stores, another, and services, which might be like Lambda functions, or Elastic Beanstalk, anything else in another workspace. It's just an example of showing how you can break it up. Now, this is a little snippet of Terraform code showing the relationship between workspaces. So up the top here, we have a Terraform remote state for a VPC. So this is a reference to another workspace where a VPC, or virtual private cloud, has already been defined. I'm deploying an Elasticache instance, and I'm deploying a RDS database instance here. And in both instances, these resources need to know about security groups, for example, that exist in that VPC. So when I create these data stores in this instance, I can refer to outputs from my VPC workspace to get all of those security group references, subnets, things like that, without having to, record, IDs of those ARNs, pass them through, cut and paste. It links together through parameters. I touched on before, basically, don't check anything into GitHub that's a secret. It still happens. None of us should do it. We've all probably done it accidentally at some time or other. One of the things that's Terraform allows you to do is actually create sensitive variables. So you can define variables in a workspace and then mark them as sensitive. So if you have like this AWS secret ID, for example, you want a contractor to be able to deploy assets into that infrastructure, but you don't want to reveal that secret to them because it's sensitive information. You can set that up and have it in Terraform so that they can't see it. They just know that it's available to them in the environment, but they can't ever inspect it. But Terraform can use that to access the cloud provider and deploy the stuff that the contractor is working on. A new feature, which has only come out a few months ago, is actually still in beta, is variable sets. So this is where you might have a set of common variables that you want to use across multiple workspaces. Previously, you had to go in and configure that AWS secret access key into every single workspace you wanted to use it in. Now you can define a variable set and have it once and just share that across workspaces, which makes it a lot easier to manage. And then if you ever have to change a key and like drop a key pair and create a new key pair, you change it in one location instead of having to go back into every workspace and update it again. It's a lot nicer. Now, switching gears for a little bit, we'll talk a bit about Mongo because MongoDB. So, how many people in the room have used Mongo before? Oh, good. So, it's a bit of familiarity with it. We're using MongoDB Atlas, the online service that they have. We're running it on the AWS. We are actually migrating from a local community edition of MongoDB to MongoDB Atlas for the application that we're working on. The nice things about Mongo is that they have a free tier that you can use on MongoDB Atlas, which is a reasonable amount of resources on there. So you can get on there, create an account, play with it, and use it for sandboxing or development with no overheads. And you can spend from like $50 a month to $50,000 a month, depending on your data and your IPS needs and things like that. Once you actually get that far, one of the key things about Mongo is it uses BSOM, which is binary JSON, as a document format. And essentially it's an optimized version of JSON where they're storing binary versions of the keys and the values. It allows you to have more data types, faster indexing, faster searching, potentially less storage space being required. Depends on the encoding of the particular variable. And Atlas, as a difference from the community edition, is, I've already talked about this already. The nice thing about Atlas is that because it is across multiple clouds, you can actually replicate your data across multiple cloud providers. So if you're sick of US East 1 going down, you can have your cluster on AWS replicated to Google Cloud Platform. So if AWS goes down, your data is still up on Google Cloud. It's not something that we currently do, but it is available as an option if you want to do that. When you deploy an Atlas cluster, you choose whether you want it on which cloud you want that on. And if you have it on AWS, for example, you can set up a private link to bring that into your own network so that all of your traffic between your applications and the MongoDB Atlas never actually leaves the Amazon network. You can do the same for Azure and Google Cloud as well. They have private links and endpoints, secure endpoints to do the same sort of peering between their network and your own applications. To interact with Atlas, you can use the shell, CLI. They have a really nice web console. And I've started using the Compass desktop application that they run, which allows you to connect to your Atlas cluster. And it has a few different features that you won't see on the online. this here is a very short document that might exist in a Mongo database. So on the left-hand side, it's essentially a category that will be used to have a dynamic list of categories in a drop-down in an application somewhere. So we have a whole bunch of ethnicity categories available with sort orders, there's names in those. The application that we have records the ethnicity of the client. So in this example, Hispanic or Latino, that's how the document is human readable. On the right-hand side is like a JSON representation of that. And if you're in Compass, you can actually change it to like an Excel spreadsheet or a table view of that. So the things to note about the document is there is an underscore ID value, which is in every document. And that's essentially the unique identifier of that document within a collection. So a collection is akin to a table. A document is akin to a row in a table, but we're obviously storing, a document, so we aren't bound by a table definition that you'd see in an RDS. Like you can have like your arbitrary number of fields in that. And these are quite simple examples, but you can do things like there's arrays, maps, there's quite complex data structures available in here. We talked about BSON before, so and this is something I didn't see until today, so that's nothing that you need to work with if you're ever using Mongo, but just something to be aware of. Under the hood, you've got some JSON, like, hello world as a map pair. It's encoded to binary when it's being stored, and it's, document size is the type, field name, the field value, and just an N flag. But this format is what allows Mongo to do things like faster indexing, allowing different data types, and what JSON has in terms of, numbers and strings, for example. So under the hood, it's doing some nice magic. Interacting with MongoDB, it's a NoSQL document database, so we're not using SQL. CRUD operations are fairly standard as expected, and you work at the collection level, which is like working at the table level. Mongo has got some really nice documentation online. So if you go to like the documentation on how to insert a document into a table, in the documentation, it shows by default the instructions for how to do it using the shell, but then you can change the language if you're using Go, C#, C++, JavaScript, Java. Like you can choose which language you want to see the documentation rendered in, and it will give you the exact API for the language that you want to use, which is kind of nice. A powerful feature of it is aggregation. So aggregation as a way of querying allows you to create multiple stages for doing a query. So you might have documents, you might filter by a value, group them together, calculate the values in them. So a lot of things here that are similar to what you might do in a complex SQL query, and then project specific values of those. So a lot of the heavy lifting can be done in the database rather than through your code. And you can do some nice things like, create views across multiple collections, which is a feature that we do use. Interacting with the database, like this is an example of how in Go, we might get a client from a collection. And so simply, we create a little filter, which is what ID do we want to look up, pass the client ID, and we, against the client's collection, we find one with that filter, and we decode the BSON directly into a local structure and return that. So in 2 lines, you can create a filter and execute a query. No injection risks anywhere or anything like that. Right, getting to the demo part of it. So I'll talk about what the demos are that we're going to do, and then we'll jump into those, and hopefully that's a bit more engaging and interesting. Feel free to shout out questions as we go through those. So I call this infrastructure as code as code. One of the things I've created is some shell scripts or bash scripts that we run to actually create our workspaces that use repositories to create infrastructure. The value in doing this is the ability to make a workspace a template. So in our company, we have multiple clients. So all the different counties in California are clients. We need to stand up application instances for each of those counties. So if we have a workspace that defines the back end of our application, We can stamp on it for Butte County, for Alameda County, for County of Los Angeles by duplicating this workspace and deploying new infrastructure for that particular county. Rather than going through the UI and creating a workspace by hand and making sure that we've got the right variables in there and we haven't missed a thing, we've actually got scripts that allow us to create those workspaces in Terraform Cloud using a REST API. And we'll look at how we use that to create a new backend for a fictitious Grant County, Florida in this demo. And we'll go through and deploy it from creating the script through to showing a working server backend for a new instance. Once we have that workspace created, so it's the first part of the demo, the second part is actually executing that workspace, which is a really fast bit, but that's the bit that does the heavy lifting and actually deploys everything into the infrastructure. So we create GraphQL APIs, we deploy Lambda resolvers, we go across to MongoDB, we create resources over there, and it essentially stands the whole thing up and runs it. Then if we have time at the end, I can make a change to a resolver and we can redeploy that and show how you can make, like, okay, we've done the orchestration, we've created this infrastructure. Now we need to maintain it, make a little change and just touch one thing in it through the same process instead of recreating everything from the beginning. This here is the last slide before we go to the demo. And this really just wanted to show how, well, it's not basic, but how straightforward it is to create resources. So in this instance, we're creating a database user on an existing MongoDB cluster. The database user is a AWS IAM role. So any resources that use that role in the AWS cloud have got permissions to this database cluster. So we have a specific role that our Lambda functions use. We can create a resource over in MongoDB Atlas that uses that role for database access. So only the Lambda functions that have that role can access the data. So it's nice and secure. There's no passwords to embed anywhere. It's just role-based stuff. We have a Terraform provider on the far left side, which is for MongoDB Atlas, and it's just saying what version of the provider to use. And that essentially is like the signature of the API to use to interact with Mongo. Some variables that we passed into it, such as the role that we're using. That role's been created in another workspace already and exists, so it's just passed in as a variable. A few specific things like the name of the database that we want to provide that role access and permissions on. And the resource on the right-hand side is a database user resource on MongoDB Atlas. So in the MongoDB provider for Terraform, the API, sorry, the documentation details all of the resources that you can create programmatically through Terraform on Mongo. This is one of them. We can create clusters, we can create database users. Some things you can't create are the databases or the collections or the documents. That's data, it's not infrastructure. Terraform doesn't do data, it does the infrastructure. But this is a resource that we're actually going to run during the demo. I'm going to create this remote user in our cluster. I'm going to give it read-write permissions on a specific database, and it will be available then for my API over on AWS to connect to and read data from. So at this stage, I'll pull my instruction sheet, and we will start the demo. So that's it for the slides. Now into demo time. Yeah. The dry run.
For our friends online. Oh, sorry. He's going to go. I was just going to say, if anybody has any questions, they can just put it on the chat and I'll make sure I'll let you know.
Sorry. Okay, so first thing I'm going to do is actually go over into Terraform. So I've already logged into Terraform. Terraform has, this is a free tier. Nothing in Terraform is costing me anything to run. If I want to upgrade, then it does things that allows me to have teams with different roles. Like if you want the contractor that comes on and you only want to give him certain permissions, then we'd sign up for the paid version and create a role for him that he can't go on destroy our production infrastructure. So in this organization, we're going to choose, for example, just a dev environment that already exists. In the future, we will have a production environment alongside of this as another organization. I map my Terraform organizations to an AWS account. If you're using AWS in a production environment and you're not doing it already, please look into AWS organizations and using multiple AWS accounts underneath that to manage your infrastructure rather than just having one behemoth AWS account with all your dev and prod and development and staging stuff mixed in together. What we see here are some live workspaces in our current dev environment. There's no smokes and mirrors here. Actually, you're seeing our dev. This is what's happening. So we have a deployment workspace, which just manages an S3 bucket. We have an IAM workspace, which manages some basic roles. We have our VPC. And a feature in Terraform now is we can actually lock those so someone can't accidentally go and run a new plan against those workspaces. They're set and forget type things, they're locked down. You can unlock them, of course, but that's not needed. This example here, CA Butte GraphQL, is a workspace for the back end of the application for Butte County, California, just as a demonstration account. From an overview perspective, there are, well, we can look at this. There's variables that we've configured against this workspace, links to the other workspaces that they use, concurrency for resolvers, how much memory we're going to give to certain resources, the cluster name that we're going to connect to, things like that. The other variables that come in variable sets that we mentioned before. So these are variable sets like my AWS credentials. So secret, key, sensitive, no one can see it, but that's available to every workspace. And the same with my credentials for the connecting to the Atlas server. Again, sensitive, no one can see it, but they're available to every workspace within this organization. So at the moment, we only have one backend deployed for one instance of our application. That's for Butte County. Our demonstration will be creating another instance of it and that infrastructure. So those variable sets here, these were actually created using the REST API. I didn't go through and manually configure these. And this is an example of how you can create stuff using the REST API. Damn it, the Zoom bar is covering up the things I need to click on. Let me see if I can, there we go. So for example, this script here is the script I use to create the variable sets. I execute this on a Linux server. I set a bunch of environment variables that have all of the sensitive values. We use a history delete so that they end up in the history of the server so someone can't go back afterwards and see them. But basically, once I create these environment variables, I can execute this script, and once we check they exist, this snippet of code is how that is created using the REST API. So we're just basically setting some headers. We're calling the Terraform API, and I'm passing the output of that to a little snippet of Python, which looks for the ID of what was created. If that ID exists, my REST API call was successful. If it doesn't exist, buffs and stops, I have to go and fix it. But this allows me to have this script committed in a repository somewhere so that when we go and create our production organization one day, I can pull this same script down and create the same variable set without having to go through manually transcribe from dev environment to prod, dev to prod, dev to prod. This is all scripted in one place, reusable script. The neat thing is setting these environment variables so that the script can pick them up when you run it, and you're just making sure that you don't check your secure stuff into GitHub, you don't put your secure stuff into the history of the server. So that little history -d line up there is gold for managing that and not making mistakes that create security risks. So that's an example of how we create those variable sets. We won't run it again because they exist already. Let's pop back over some MongoDB Atlas now. So when you come into, this is the online, the UI for it. You can also use Compass, which is a desktop app for interacting with the same thing. I'm using the free tier for our dev environment right now because we don't need some of the features that you get with a paid environment. But in this cluster, we have collections within databases. So here's a list of the databases that we have, for example. So here's the database for Butte County, the one demo, the one example that we currently have set up. And we also have like an administrative one here. One of the features that we've done is we have some default categories, default user groups, for example, that every deployment that we do needs. So we have those set up there as in a default collection. When I create a Grant County backend, I have written code that just takes that data and pushes it through. That's not part of Terraform. That's just a shortcut I've done. Terraform doesn't manage your data, it manages your infrastructure. But you can see down here, here's a collection with all of our clients. This is all dummy data, for example. So, for example, here is a document that is for a client. And this is all dummy data, as I said, they're not real people. There's his, you've got 2 addresses in the document. He's got a case open. He doesn't have any events, it's a brand new case. And we have collections of multiple clients, but then there's a view that's being created programmatically to view all the clients, just like you might set up a view in an RDS, or a relational database system. So during the demo, we're going to create another database here and we'll populate that. And we should get to the point where we can actually query clients in that sample database that we created. Now, over in, what I'm doing here is just switching roles in AWS, which is actually switching AWS accounts from a sandbox into a dev environment. Again, look into AWS organizations if you've never used it. So in this environment, what we're going to do is we'll start our demo by creating a new database for a fictional Grant County, Florida. We're in Lee County. I figured Grant should have one as well. So we're here in development. We will go to I don't want to create. Am I logged in? Nope. Being in the correct region helps. So this is AppSync, which is AWS's implementation of GraphQL. Everyone here is familiar with GraphQL? Okay. Emerging API standard as an alternative to REST or RPC. It's developed by Facebook originally, actually, and it's quite popular now. So this particular API that I'm using right now, I just need to put an authorization key in here for this to work. So I'll grab that from my tokens. Because this is an authenticated API, so I need to have credentials for it to run. We're going to create a new deployment. So let's create a database called Florida_Grant. You might be right, because it is pre-populated in the drop down. You're right, thank you. Well, you would have seen the error handling. So back to here. So we're going to create Florida_Grant as a database deployment. And we'll call it Grant County, Florida. This is just stuff that's used as. Yes. This is behind the scenes. This is actually calling a Lambda function that I've written to populate data. Okay, so yeah. Yeah, so this is a GraphQL query, a GraphQL mutation, which is essentially like a write query. It's going to call it a Lambda resolver on the back end, and that Lambda resolver is going to connect to my Civitas database, copy all the sample categories and things that are there, create the empty collection names. This is a data step. It's not related to Terraform. It's just part of the prep I need to do for the demonstration. Okay. But the nice thing about it is whenever we need to stand up a sandbox or a new dev environment or a test environment, I've got a Lambda resolver written that lets me populate it with 100 dummy users. Lambda resolver responds to GraphQL. Yeah, so it this new deployment mutation is mapped to a Lambda function. That Lambda function takes in the database name, the name, the number of seats to create as variables, and it executes. So if you want afterwards, I can show you that it's just a Golang Lambda function. So when I run this, what we'll see, fingers crossed, is a new database created over in MongoDB Atlas called FL Grant. I'll come back over here and refresh. Oops. Okay, so here we have a new database. It's just been created. The 90 sample categories are being copied across from my table here. My 3 sample user groups are being copied across. So we have a new database. It's pre-populated with some basic data. That's just a scripting step I've done. It's not part of Terraform to do that. The next part, though, is something that Terraform will be doing. For database access here, we don't have a user that can access that database yet. I've got one that can access an admin one, SIP user. I have one for the Butte County, but I don't have a Florida Grant County permissions in Mongo yet. That is something that we will be creating through Terraform. So this is part of the multi-cloud where we execute one workspace and we can go and create resources in Mongo and AWS at the same time. So we've done that, beautiful database. Now, just another step as well that we can do here from my admin API is we can now populate that with dummy users. So if I have a script that populates that with 100 dummy clients. So we have some stuff that we can run test reports against and things like that. That'll take about 30 seconds to execute that one. So while that's actually running, it's creating collections and documents over here. So if we go back into those collections of the Grant County, we'll see that there's a new collection being created there, and dummy clients have been created in there. The way I do that is I have a set of sample names, dummy SSNs, dummy addresses, and I just mix them and create 100 random clients from those. I have to create that much test data that it was worth spending 2 days to sit down and script all of that and have it available to click a button and, wait 30 seconds and populate dummy data is true. Much faster. So now that we have a database created and we've populated with some sample data, we are going to, I just need to do one last step, which is fake creating a new user in there. So one of the things you can do is actually copy a document from one collection into another collection. I can insert a document. I can paste that in. So I just force created a new user in this database so I can log in through the API. That's just, you didn't see that. It's something I had to do for the demo to work. Now, what we're going to do in Atom, which is my IDE of choice, is we're going to create a new workspace script. So we have this script here called CA Butte Graphql, which is all the Terraform REST API steps required to create a workspace, set all the variables required in that workspace. This is my template that I'm going to use. Every time we deploy a new instance of our application in a new workspace, I can take the script and duplicate it, make a couple of changes in it to the name, and I can run that and programmatically create the workspace. So this is a little bit of what's calling infrastructure as code. Normally you would have to, if you didn't spend the time to write this script, and I will be popping this into a public repo because it's such a time saver for us, you would have to manually configure that workspace by hand, and you spend a day doing that.
So when you put the script, Terraform script together, like, so if you're new to it, say I just started with it, is there a way to like debug like incrementally through each line work? Or
yeah. You can add resources and do it incrementally that way, but when you're in a workspace, you can plan it. Like you can run a plan and it will tell you if it works or not. So you can do a plan that doesn't execute. So you can run a plan and see, is my configuration valid? Will it work if I hit the apply button? So it is possible to do that. I've got a whole bunch of ones I've built up over time that do work. So when we run this one tonight, we'll be creating Lambda functions, some IAM roles, a GraphQL, API, Mongo stuff. Like it's going to pump a whole bunch of stuff in once.
Two lines before it, but there's a lot of lag.
No, it can take a while for infrastructure to deploy. One of the smarts of Terraform is that it will work out the hierarchy, like the order of precedence in terms of what needs to be created first. It won't create a Lambda function if it hasn't created the role that a Lambda function needs, for example. It'll say, oh, this role is a condition precedent. I'll create the role first, regardless of what order you have it in the script. So Terraform will work all that out for you. I've had appliers take 20 minutes because it just takes that long to go and build all the resources that it's going to go and do.
So it's one of the resources.
Yeah, it'll take your script and it will create a plan from it, which is working out order of precedence, checking the state to see whether these things exist or not, which ones do or don't need to be changed, which ones are the prerequisites for other ones to do it. So yeah, it's when I have trouble with Terraform is because I've gone into the console and gotten patient and deleted something manually and screwed my state up. Like once you start using Terraform, you use Terraform for all of the infrastructure in the space. You don't go and change something in the back end in the console. That's the idea of what you're trying to get away from. So to make our workspace here, I'm going to take my script, I'm going to duplicate it. I'm going to call that, so this is a script to create a new workspace instead of having to manually create one by hand. So we'll create a workspace for fictional Grant County. And in here, I'm just going to search for references to Butte. So that's, let me already bring it. That's just a comment. And what I'm changing here are references to other workspaces, the name of this workspace. So I think I have 5 references I need to change. A workspace is a way to abstract or modularize your code. So you could write, if you're using Terraform on the command line, you don't have workspaces. Workspaces are a concept that are found in Terraform Cloud as a way to organize groups of modules together. So in your actual Terraform code itself, because this is just a bash script, in your Terraform code itself, you won't have any references to workspaces unless you're pulling in attributes from another one. But you don't write your workspaces. This bash script in Python is stuff that I've invented effectively to shortcut this process. Like if we was to make this workspace by hand and you have a bug in it, you got to debug, this is like a 5 or 6 hour exercise. This is when it runs, it's a 5-second exercise because it's something that we've scripted up. Okay, so we've done that. What I'm going to do now is I'm going to push that to GitHub because I'll go to the repo for that, which is my common workspaces. I'm just going to commit it and push, done. Okay, now, so I've created a new bash script. I have like a little Bastion server. If I'm still logged in, nope. Thought that might happen. I'll just log into this. Here we go. This is just a Linux machine. I have a directory on here which has all of these shell scripts on there. What I'm going to do is pull down from GitHub that repo, and that'll give me the new script that we just created. Yep, so you can see here, it's found a new shell script. Now, the one thing I need to do is copy my keys across. So these are temporary keys I need to delete after this presentation, so no one can use them for anything. What I do is I set environment variables in the shell. If you check my history, they're not in the history. So that little minus history minus D removes them, so this keeps your data secure. Now, we've got our script on this Linux server. We can now execute that. Oops. Stop it. And we're going to specify the target organization for this. Now, as I said, this is a script that is essentially my invention. I'm going to pop it into a public repo later on so that it's available, because it's a massive time saver if you do start working with Terraform. Now, this is using the REST API for Terraform and using those environment variables to go ahead and create a workspace, links to the repository that the workspace resources and Terraform configuration lives in GitHub, creates all the variables, creates all the references to other workspace that it needs. Failed trigger deployment. Triggers always fail for some reason. I don't know. It's just a bug that they have through the REST API. But if I go back here now to Terraform and I go to the workspaces, we now have a Florida Grant GraphQL workspace that's been created in seconds. The triggers that failed just then are triggers for, where are we? Run triggers. Yeah, it always seems to fail on one of them. Basically, what these triggers are, if there's a change in the IAM VPC deployment or messaging workspace, it says, oh, things in this workspace are reliant on changes in that workspace. So if I made a change in my messaging workspace, which is where I might run some SQS queues or endpoints for like topics and things like that, SQS or SNS in AWS, like notification services, those changes trigger this workspace to be planned. Say, hey, you might have resources that depend on this queue existing or not existing anymore. But all the variables that were needed have come across from that script that we just created. Grant County, the deployment is Florida_Grant. That's the 5 places I was changing things in the script. And the workspace exists. It is hooked up to a GitHub repository. It used my VCS credentials that I pasted into the environment variables when we ran the script. And it says, you know, the Civitas Terraform GraphQL web repo contains all of the Terraform configurations that are needed for this workspace to manage all the infrastructure that's needed on Mongo and AWS. Moment of truth. Not a plan. So this is now going to pull from GitHub the Terraform scripts for all the infrastructure that I want to create for this to be a new backend. It's going to go through, check that all the prerequisites exist and the dependency workspaces. So make sure the network exists. Make sure that, you know, any queues exist, deployment buckets exist, Lambda functions exist. Green across the board, which is nice. So this is planned. It's going to give me a list of all the, so back to your question, Ron, about, you know, if there's changes, these are all the changes that are needed. If I change one thing in the future, it's just going to tell me that one change is needed. So if we go through here, we're going to create an API key on a GraphQL. We're going to create some data sources. We're going to create some mutations on that API. All the way down, we're going to do some policy attachments to allow simple queue service to send to Lambda. Like all this infrastructure is going to get created when I hit this confirm button. This is where it falls over. You watch.
The database with this fragmentation mechanism.
Yeah, so this is going to create all the resources on AWS that with my business logic, my GraphQL API, and it's also going to go across to MongoDB. We can see the third last resource that it's planning is creating a database user over in Mongo. So this has actually hit two different clouds, a whole bunch of AWS resources and the MongoDB Atlas cloud, all created at the same time.
But I'm not sure what is the benefit. Is it to have it in multiple places for like security?
Oh, for the database.
Or
Oh, for the database. Why am I using Mongo instead of?
No. Why do you have it? Why do you want to have it in two places? Is it, for example, are you adapting the code to any specific line? Is that what you want to replicate it? Is that why?
I think what you mean. So this example here, I'm running it for one specific county, which would be one deployment of our application. If I have 15 counties to service, they each get their own version of the application and their own database. So yeah, it's not a multi-tenanted system. They all get their own database and backend.
So it's a different data sets.
Yes.
And same backend. Same. So if I make changes to the code, replicate.
Oh yeah, if I have a bug in my API, for example, and I fix that bug, I can run all the workspaces for all the different clients and patch the bug in each of those. Yeah. So
I'm not sure. So you're the one shell script batch. It actually don't provide information it's needed by Terraform script, correct?
yes.
So here we have to modify that one script for each of the different ones, but it's still using the same one Terraform script.
Yeah. So Butte County and Grant County use all the same scripts. I've just stood up an entirely new instance of our infrastructure and application during the course of this demonstration. So if let me just make sure I don't miss any steps here. Okay, so we can now see that some of these resources have been created. If I go back to Mongo and look at the database access, and we'll refresh that. There is a refresh button. Ta-da, here we go. So this resource has been created now over on MongoDB Atlas, which is an IAM role-based user, which only has read-write permissions for the Florida Grant database. So we've been able to create this database. And we've been able to create access permissions to that are then used by resources over here. So now if I go to refresh this is AppSync, I should have a third API. The data source behind it, they're all new instances of Lambda functions. This has all been deployed by executing that workspace. So totally duplicated backend to service a specific client. And because we're dealing with government clients, they all want to have their own instance. They don't want to share anything. So we have to have their own database, their own backends to serve each of those. And we should be able to now demonstrate that this all works by, if I do a login, I should be able to log in as the test. Remember, I copied the document from one collection to another one. I copied a user across. So we have a test user that exists there. Nice and secure. Works. So there we go. We now have a token back, which I can use to make others secure. To create test users, yeah, I did test. I can now do a query and look up some of those dummy clients that we created. So let's look for all the open clients. Oh, a security feature that we have. We're not talking about Lambda tonight, but AWS have introduced some more authorization models for GraphQL. So when I execute a query, I'm having a Lambda function that just handles authorization. It's not a little middleware layer. and I can pass it like my authorization token for my user. It can look up the roles and permissions of that user to see whether it's authorized to access the query or the mutation I'm trying to run. So that's what I'm doing here. So I'm passing a token across. So my query isn't authorized to be run, so this will fail. But if I change that to a named client list, this user is allowed to use client list. This will give me a damn it. Damn it, fell over. Well, what would happen before? Like if we had like for the login, you don't have a user at the moment, so you have an API key to access this API. So here's the API key. If anyone possesses this key, they can attempt to hit the login of this the login mutation. Once they're logged in though and get back a specific token for that user, you can either just keep using the API key, and then you have to put all your role and permission type checks into your business logic in each resolver behind the scenes. What we have here instead is there's an API key that's been created to access it. The additional authorization provider is this FL grant GraphQL authorizer. It's a Lambda function. The code already exists for it. It's exactly the same code as Butte County. And it has all the business logic inside of there to look up a user, look up their permissions, see whether the function they're trying to, the query or mutation they're trying to execute is within their allowed permission set. So it's adding a step before each thing, but it's more fine-grained than just using an API key to.
It looks like this is a pattern that AWS is designed, because I see that like Lambda Authorizer on. So like it seems to me like they have like AWS Lambda has this idea of using Lambdas for authorization. That this is a pattern.
Yeah, this is a relatively new one. There's a few different authorization modes for GraphQL. You can use IAM roles, an OpenID, Cognito, if you've used AWS Cognito before.
But it's like sometimes people have this like I don't know if it's like the right term, it's like Apogee, but
not Apogee, but Amazon does have an API gateway product, which is an alternative to GraphQL. It's like if you're deploying a REST API. But this Lambda authorizer, it's like a little piece of middleware that you write yourself just to handle the authorizations, and you can have it as basic as, yes, this is a valid token that hasn't expired, I'll let the user through, or okay, the user's trying to run a report. Does this user exist in a group that has permissions to run that report? Yes or no, and it will pass back a true false flag basically. If it's true, it lets the user progress and that function executes. If it's false, it kicks you back and says that you weren't authorized to run that. So that was really the aim of the demonstration, was to be able to deploy a new backend for this fictional Grant County, which has happened there. Just to humor me for 1 minute, if we were to make a change, we just need to update something just to do an incremental change now, like managing our infrastructure, not orchestrating new stuff. I might make a change to, well, I might change a comment in a piece of code, but that's enough to have a new executable. So if this is an example of where I use the local Terraform to take a code artifact that's compiled on my PC and move it into the cloud into a bucket. So this is the only time I use Terraform locally or the local state. And I actually have a couple of little build scripts up here that I can run. I won't go into details of those, but to demonstrate how that might work. If I'm in my build directory, I can run a little script that compiles my code. You'll see it wrote a zip file, client zip. Now it's going to run the Terraform locally say, hey, does the clients.zip on this machine have the same hash as the clients.zip in the S3 bucket that's previously been deployed? And if it differs, and it should because I just made a change to a comment, it'll push that across. And then that's available for my workspace to pick up and deploy. So you can see here it's planning. It's going to change one Lambda function. In a moment, that'll be sitting in Oregon once this finishes running. Still modifying. It's usually much faster than this. It's only a 7 megabyte artifact, so it shouldn't take too long. Oh, come on. This is usually the fastest thing every day. Yeah. The up speed might not be great. There we go.
What parts of the Lambda are terraforming? I guess we're still building this Go application, mostly right Go application, and then we just are using Terraform to deploy this.
Yes. Yeah. So the step they're up to now, I've deployed this Lambda. That was a Lambda function we just built. It's been pushed over to an S3 bucket sitting in Oregon. And now if I go back to Terraform Cloud and I plan this workspace again, it's going to refer to all the objects in the bucket and the state that the workspace currently has. And it's going to go through and say, oh, here's a new code artifact. It's got a different hash to the one that's in my state. And this plan will say, I just need to deploy this one Lambda function onto AWS. So
the right answer to this package that totally already know Terraform. So
yeah.
I'm more interested in your in the other technology.
Okay. Yeah, that's one question. So yeah, you can see here there's so there it's picked up the change to the clients function. And okay, it must be attaching that policy to that new function as well. But yeah, so instead of having 42 steps to deploy with infrastructure, it's just going to now apply the incremental change. So we're now into the management phase of our infrastructure, which is deploying new code artifacts. And all I'm doing is deploying something I just changed the comment in.
That would change on all of your platforms.
No, it'll change it within this workspace. So yeah, but if I went back to CA Butte County and run it there, it would also change in here. It'll pick it up. It might pick up a few more things actually. This might be a little bit out of date, this workspace. But were you asking more about looking at what the Terraform configuration looks like for the Lambda function? Or
Yeah.
okay. So that there, I have a repository here. We haven't looked in this repository. This is the repository that contains all of the configuration for that workspace that we just deployed all that infrastructure for. So to look in here briefly, this is the main entry point. We have dependencies on the deployment, IAM, messaging, and VPC remote workspaces because we're going to use foundational stuff that was set up in those. I've got an app sync module, which is where we create our GraphQL. There's an IAM module where we create some specific policies for Lambda. I deploy a scheduled Lambda function, which is for report generation. But Lambda Web is the module where I'm deploying all of the Lambda functions that become resolvers for GraphQL. You can also see down here, there's also a MongoDB module, which is going off and creating the authentication resource over on Atlas so that we can connect to that database. So if we dive into what this might look like, for example, the clients, this is the Terraform script for deploying that client's Lambda function. So there's a reference to the zip on a path in an S3 bucket saying this is the resource that you should be grabbing and deploying into Lambda, and doing lots of parameterization. Like once these are created, like if I was deploying what's one that doesn't exist there? referrals. If I needed to create a referrals function, for example, I just copy this client's TF, make a referrals TF, go through and just change a few references to point to the specific code that is going to contain all of my referrals business logic. But yeah, this resource block here tells Terraform what to create in AWS for this specific Lambda function. And you can see here we're getting some, you saw some of those variables I created, like Grant was a variable. So county of Grant, Graphql resolver. So when we look in Lambda functions on AWS, you'll see that there is a county of Grant function. Oh, page 2. County of Grant GraphQL resolver for clients. That's a string there that's been created from this piece of Terraform scripting here. And we do things like we set secrets to get access to resources. We set the amount of memory that that function's got available, how many, whether it's concurrency, like, single instance or 10 instances can run at once. If it runs for 30 seconds or 15 minutes, pulling in the subnets that were created in another VPC workspace. So normally to deploy a Lambda function, if you do it through the UI, you've got to go in, you create a new function, you have to manually set all of these variables. Because we've scripted it all through Terraform, it's just going to pick it up from the outputs of those other workspaces. You haven't got to go through and create that manually every single time. And if you have one function that's not working, you got to go through and debug and work out, oh, I'll put the public subnet, not the private subnet on this particular one. You got to wade through the UI to find that sort of thing, instead of passing in some variables the exact subnet that you wanted. So that was kind of the extent of what I wanted to do for the demo. The last thing I wanted to show, which hadn't been in Terraform last time I did this, was some of the looping functionality that you can do. So the Terraform scripts can be quite long and verbose. There are some constructs, like, I can create a variable that's an array. So this array is a list of all the queries in my GraphQL function. So there's client details, client edit lists, and client list are queries. This resource template down here is exactly the same for all of those, except for that one variable. So you can actually write a looping construct in there, so that, create this AppSync resolver resource for each of the variables in this array. So otherwise, you'd have to have this particular piece of code duplicated 3 times throughout your script. I do the same thing up when I deploy stuff locally from my machine. If I want to deploy a new function, module web Lambda, here we go. So for all the Lambda functions I stick into an S3 bucket, I just have a list of the names of the zip files I want picked up. And this resource will just iterate over that list and pick up the zip file called authorizer zip, admin zip, client zip, report zip, user zip. If I wanted to add another one here, I would say referrals, if that was the code I was creating. Next time I run this, it'll pick up referrals and stick it in the bucket for the first time.
So if you did the forward reporting data from every one of those, so it says that's just what you use Terraform to grab all the reporting data.
The reporting data.
So like stats for upper management or something, like they want to know how many people are using the system, or.
Oh, in terms of like the application that we're writing, like reporting out of that. Yeah, so it's a Lambda function. Does it queries Mongo and creates report data. GraphQL API is where you would interrogate that. So the Terraform is only used for creating that infrastructure and deploying it. The actual application functionality, which is, generate reports on the number of people that still have an open case, for example, that's just something in GraphQL. Terraform doesn't know about that except for when it first deployed those resources for you. So, yep. Well, that comes back to, when do document data stores make more sense than a relational database. In this particular case, it's legacy. But a document store makes a lot of sense in this instance. Like if we want to refactor, so at the moment, our code handles supplemental security income cases. If we wanted to handle disability housing, that's a new type of case. If we had a relational database system, we'd need to make modifications to our schema, like altering tables. With a document database, you just add those attributes to the documents that you're storing. You don't need to go and refactor your database schema to do that.
And that's just the choice of the application. Exactly.
Yeah, you could.
Terraform and state a bunch of Windows servers on Azure.
Oh yeah, for sure.
You don't have to stand up a SQL server or whatever it is somewhere.
Yeah, for
When Terraform is just stand up the infrastructure.
correct.
How the application.
No, the choice of MongoDB is a architectural decision for this application. It's not related to Terraform. But if you were looking at a data store independent of Terraform question, then it's a document, like a NoSQL versus SQL is the answer to that. Really, there's scenarios where a document data store makes sense. There's scenarios where relational databases make sense. We could have used RDS or MySQL to implement the data store for this. But
I think the person asked the question, they were going down the application versus the infrastructure.
yeah, so
What Terraform is for.
yeah, so the application answer is document versus NoSQL, NoSQL versus SQL. But in terms of infrastructure, we could deploy any data store that there's a provider available for. And one of the examples I showed earlier was actually deploying an RDS instance. What was the second question? Is it in the chat? If you're using S3 for the backend, you're limited to using the CLI for interacting with Terraform. So you don't get some of the features of Terraform Cloud, like separate workspaces. I think the S3 backend made sense when Terraform was just a command line product. But if you were trying to do, if you're using a team and have multiple developers, or if you want to use the feature of multiple workspaces, Terraform Cloud is free. Like you can use it for free. There's, you don't have to go to the paid version. So I far prefer working with cloud than I do the CLI. I just find it much more productive to use cloud. So I don't have a use case for S3 as a backend for state storage anymore. Pre-cloud, there would have been a use case for it, but I don't have one today. So.
Did you evaluate Pulumi versus Terraform?
Oh, what was the second product?
Pulumi? Did you
No, I've been using Terraform for about 4 years though, so for 3 years though. Haven't found a need to change away from it. Started down the cloud formation path on AWS and quickly switched to Terraform and fell in love with it and haven't found a need to move off. But yeah, that's not to say it's better than other products. It's just my tool of choice. Cool. And after a lot, I tend to talk fast. I dump lots of information, and it's the sort of thing that people hopefully you can go home and digest and think about. And one day you might see a need to investigate the product and use it in a project of your own.
I would say as someone who has written a lot of Lambda functions and figure a lot of Lambda functions, that's an amazing tool.
Yeah, I don't deploy code anymore without using Terraform. It's a must-have for me. It's like, I won't do it.
That's
Old school.
That's terrible.
Yeah. Okay. Well, thank you, everyone. That's it. We'll get over here.
This is for JetBrains license. Okay, that's the number.
It is 8364 60. So 60 for the last two, 460.
460, you have it? Okay, that's.
Do you need it?
Awesome, thank you.
Okay.
Okay, I guess. Okay, let me see
Finish
if
up
I
Zoom.
can. Yes. Wait. Wait. Okay, thank you everyone for the ones that are online, and we see you next month. Thank you.